All right, let's jump right into it. Today, in this explainer, we're decoding something that sounds entirely like science fiction, but it's actually bleeding-edge physics. We're talking about the TAFCM propulsion prototype. Specifically, we're going to look at exactly how this system mathematically extracts thrust directly from the localized quantum vacuum. I mean, think about it. No exhaust plumes, no burning rocket fuel, just pure, unadulterated topological momentum.
So to really get this, we have to confront what engineers often call the tyranny of standard rocketry. You know the deal. Traditional symmetric propulsion is, honestly, fundamentally wasteful. You burn a chemical fuel, the gas expands isotropically, meaning it just pushes out in literally all directions. So you're wasting a massive amount of energy on radial expansion, all while dragging around heavy, deadweight reaction mass. But here is the paradigm shift: topological confinement. By confining electromagnetic fields locally, we can create an anisotropic, or strictly directional bias. Basically, the vacuum itself becomes the substrate we're pushing against.
Okay, so to achieve this wild idea of propulsion without propellant, we first have to understand how to shatter spatial mirror symmetry. That brings us to Act 1, the geometry of the knot. The absolute foundation of this whole system is the T32 trefoil. It's a specialized chiral magnetic cage, and chiral just means it has a strict handedness. In this particular case, we're looking at a left-handed knot. As you'll see, the path wraps 3 times longitudinally and 2 times meridianally. And because there is literally no rotation in 3D space that can ever make it match its own mirror image, it shatters parity by design. By forcing energy into this specific asymmetrical shape, we establish a heavily biased momentum direction that nature is, well, mathematically forced to obey. Now, to quantify that geometric twist, we rely on one of the primary governing equations of electrodynamics for this setup: magnetic helicity. It's the integral of the magnetic vector potential, that's the A, dotted with the magnetic field, B. It's a rigorous way to measure exactly how knotted and linked a field is in 3D space. By confining our working fluid inside that T32 cage, we're artificially injecting a massive, mathematically unbalanced twist right into the vacuum fields. And when we map Biot-Savart vectors across this specific trefoil winding path, things get really interesting. The system actually drives the local environment past a critical helicity threshold of negative 0.019189 Webers squared. And that negative sign? Absolutely crucial. It mathematically guarantees a left-handed chiral dominance. We're essentially building a localized magnetic pressure gradient where the field lines bunch up together, kind of like a tightly coiled spring, just waiting to snap. So moving from the mathematical theory into the visceral, physical reality of the machine, let's look at how this geometry is actually built and powered in Act 2, the electromagnetic motor. This hardware stack is just an absolute marvel of engineering. The designers completely ditched heavy, traditional nuclear cores in favor of a 13-gate pulsed architecture. The physical chassis itself is a peak in titanium mandrel wrapped in these insane 5 Tesla RBCO superconducting coils. And inside? Room temperature liquid Gillenstein, an alloy of gallium, indium, and tin. And driving all of this is the power stack, which is a massive 50 megajoule supercapacitor bank that is just primed and ready to dump its energy directly into that fluid. Here's where the second critical equation comes into play, the Lorentz force. Force equals current density crossed with the magnetic field. By holding that 5 Tesla magnetic field totally steady and then pulsing a massive electric current right across the liquid metal, the Lorentz force completely takes over. It violently reaches out and just shoves the Gillenstein ions laterally through that twisted loop. And it does this without a single moving mechanical part. No turbines, no pumps.
The defining metric of this state is this extreme Hartmann number right here, 6,645. Now, in fluid dynamics, this number represents the ratio of electromagnetic forces to viscous forces. At a value of 6,645, the magnetic field is gripping the free electrons in the Gillenstein so incredibly tightly that it completely crushes all fluid turbulence. The liquid metal is forced into a solid plug laminar flow. At this point, you aren't really pumping a liquid anymore. The system is literally dragging the liquid metal through the pipe like a solid, frictionless brick.
All right. Now we arrive at the violent climax of the whole process. This is where the actual thrust is generated. Act 3, the momentum transfer. To actually get that thrust, we need an extreme event. That 50 megajoule supercapacitor bank dumps 12.5 kilovolts and 75 kiloamps into the Gillenstein in under 2 microseconds. Let that sink in. Like the chief architects noted, if we want to extract momentum from the vacuum, we don't need a steady hum, we need a scream.
That microsecond transient pulse forces a really brilliant four-step chain reaction. First, it squeezes the fluid. Second, it snaps the magnetic lines right at the absolute boundary of confinement. Third, it kicks momentum out anastropically. And finally, fourth, it couples that kinetic force directly to the physical frame of the craft.
When the primary stator coils squeeze the knotted Gell-Instan, it actually can't compress symmetrically because of that chiral shape we talked about earlier. It gets driven to the absolute boundary where the topological constraints are violently violated. The magnetic lines are forced to reconnect just to conserve that helicity. And as a result, the momentum squirts out strictly in one direction. It's exactly like taking a soaking wet, twisted towel and wringing it dry.
But how does a magnetic snap actually move a physical machine? Well, that snapping creates a massive directional burst of alpha waves. These waves travel right back up the RBCO magnetic field lines and transfer that massive kick into the titanium frame. And this force is so violent that the system actually requires a viscoelastic compliant interface layer, which is basically just graphene-infused shock absorbers, so the machine doesn't literally shake itself to death during that microsecond pulse. By coupling this internal, localized force to the chassis, the system effectively creates a closed-loop push against the external magnetic fields and spatial vacuum surrounding it.
And honestly, the results are just staggering. Empirical Phase 2 simulations project an estimated peak thrust of 5,000 newtons from this benchtop rig. To put that into perspective, that means the system is generating over half a ton of physical force. That is enough to actively begin counteracting local gravity. And it's doing it without burning a single drop of chemical propellant. It's a real game changer for how we might navigate gravitational wells in the future.
So where do we go from here? Let's take a look at how this builds from a raw laboratory physics experiment into a functional, world-changing technology in our epilogue, from benchtop to aerospace assets. The long-term roadmap here scales this benchtop momentum exchanger into a fully-fledged toroidal aerospace vehicle. By transitioning from Horizon 1, the lab testing phase, all the way to Horizon 3, the design drops those heavy onboard power mass constraints entirely. By riding these localized field interactions, the craft leverages external magnetic fields and directly subverts ambient gravity, powered remotely via microwave energy beaming right to the hull. It effectively becomes a true flying donut that interacts seamlessly with the planet's magnetosphere. Which leaves us with a final and pretty provocative thought. We've just seen how shattering spatial symmetry and leveraging intense, pulsed magnetic helicity can generate real, tangible physical force. If we can literally, mathematically wring momentum directly from the quantum vacuum without a single drop of fuel, what limits how far and how fast this topological architecture can truly take humanity? I hope this explainer sparked your curiosity as much as it did mine. Thanks for diving into this with us.